Okay, Assalamualaikum dan salam sejahtera. Okay, untuk minggu ni kita akan cover concepts in discrete event simulation. Okay, oops. Okay, so basically, let's do a recap first what we have learned so far. Okay, last week you have been introduced on the basics of simulation. Okay, so we have go through simulation using spreadsheet. Okay, so I have demonstrate you how to conduct a manually simulation, okay, using a spreadsheet. So in through that spreadsheet, we have seen how a random number being generated, okay, by random number generator, which is through a function in Excel. And we have also seen the use of simulation table to organize the simulation, okay, and how we go through the simulation steps. Okay, so in this lecture, okay, we are going over the major concepts and building blocks in DES, okay, in discrete event simulation, and learn how the relationship between the components and the interactions between the components. Okay, so last time we in the last lecture we only seen only a simple simulation, okay, using the spreadsheet. But as in as the system is getting more complex, okay, so then we need to use a simulation table that is slightly different than what we have seen in the Excel spreadsheet, which we will go through this lecture. Okay, firstly, okay, let's talk about discrete event simulation. Okay, so basically discrete event simulation, as we have talked previously, it's model a queuing systems. Okay, as they progress through time. So what does it mean by queuing system? Okay, queuing system ni meaning that a system that consists a queue. Okay, sebagai contoh, a simple example is the bank, right? The bank in the bank system, we have when the customer arrive at the bank, they have to go into the queue before getting the service at the counter. Okay, that one example of queuing system. So basically, DES is used to represent a system, okay, as entities or objects flow through a network of queues. A network of queues and activities between which resources are shared. For example, okay, if you can see from this, this is an example of a queuing system, okay, where entities ni object, okay, flows through a network of queue. Okay, you can see from this picture there are multiple queue system. Okay, there are multiple. So this is number 1, this is number Q, number 2. So there are two queue line here. Okay, and we can see that resources, okay, being shared among activities here. Okay, so the entity, the object, okay, can flow through this system, okay, and exit the system. It can also flow through this way and exit the system. So as the entities, okay, as the entities move from location to location, they change the state of the system. That's the essence of discrete event simulation. As they move from one location to another location in the system, okay, it changed the state of the system. Okay. Another thing is that the state variable, the state variable only change at a specific discrete set of points in time. So, for example, in the bank, the number of customer, okay, the number of customer, which is the system state. Normally the system state is something that we can measure lah. Okay, the number of the customer changes only when a new customer arrive or when the service provided to an existing customer is completed. So for example, in this paragraph, you can see this is an example, a discrete representation, okay, of the state variables. So kenapa dia discrete? Why it's called discrete set point in time? Sebab, okay, when the customer arrive, okay, it happened at discrete time, and the customer depart from the system also happen at discrete time. So kita only track arrival and departure, for example, okay, to measure the number of customers in the system. So from this figure, okay, I hope you try to understand this figure, right? Okay, what it means by this figure. Okay, for example here, this indicates that the arrival, okay, because this is a figure that show you the number of customer in the system. Okay, so this point marks the arrival of customer, the first customer. So the first customer arrive, the number of customer in the system become 1. Okay, here 1. Okay, so this is at time 2, at time 2, and this is at time 3. So what happened at time 2? At time 2, okay, what can you see here? What happened actually here? What happened here? Okay, this is a representation of the customer, customer 1, and this is customer 2, this is customer 3. Okay. Hold on. What happened here? Okay, this is customer 3, customer 4, and so on. Alright, so what happened at this point here? Okay, as you can see that the number of customer in the system remain the same, but at this point you have customer 1 and customer 2, right? In this area. So what this means is, even though customer 2 already arrived in the system, but the number of customer in the system remain 1. Okay, remain 1 here. So that means customer 1 actually depart, customer 1 depart the system here. Okay, customer 1 depart the system at time 2, and customer 2 arrive, right? Arrive at time 2, and then customer 2 depart the system at time 3. Okay, time 3, because now the system have 0 customer. Okay, from 3 to this is 6. From 3 to 6, this is 0 customer. Okay, 0 customer. So when customer 3 arrive, right? What happened here? Customer 3 arrive here. Okay, this is customer 3 arrive. Okay. Here customer 3. Is it customer 3? What happened here? Not customer 3. Actually, what happened here is customer 4 arrive. Kat sini, customer 4. So when customer 4 arrive at time 7, okay, at time 7. So what happened? The number of customer in the system become 2. Become 2. Okay, you can see here 2. The number of customer become 2. Okay, at this point, at time 7, there are customer 3 and customer 4, meaning that at time 7, customer 3 is still in the system. So when will customer 3 actually exit the system? So you can see that here, what happened here? Okay, at the next point in time, what happened? Okay, this is at time 9. Okay, so you can see that now, after time 9, the customer in the system become customer 4 and customer 5. No more customer 3. So that means customer 3 exit here. Okay, at time 9. Okay, here customer 3 depart the system. Okay, so at the same time, customer 5 arrive. Okay, customer 5 arrive. So customer 4 is still in the system here. Okay, and then customer now what happened in another next point in time, which is at time 11 here. Okay, at 11, from 2 customer in the system now become drop to 1 customer in the system. So meaning that here is customer, this one is when customer 4 depart the system. Okay, meaning that customer 4 already received the service and it exit the system, but customer 5 still remain in the system. Okay, and so on lah. Okay, so I hope that you can understand this figure. Okay, so maybe in the test I will ask you how to interpret. Maybe you will be asked to interpret this figure. For example, maybe I can ask you, when will the customer 3 arrive or depart the system? Okay, or maybe I can give you some information, arrival and departure of the customer, and you may need to recreate, okay, this figure to represent the number of customer over time in the system. Okay. Okay, this is the terminology used in discrete event simulation. Okay, I hope that you get familiar with this terminology. Okay, so the first one is the system. Okay, this is actually the summary lah. Okay, system, model, system state, entity, attribute, list, event, event notice, future event list, activity, delay, clock. Okay, so the detail yang kat ada in the next slide. Okay, so system. What is system? System ni, sorry, not system. Entity. Okay, entity. What is entity? Let me check first. Sorry. Okay, saya punya slide ni selalu kejam-jam lah. Okay, system first. Okay, system. What is a system? It is a collection of entities. Entities ni contohnya ialah people, parts, machine, okay, object lah, object in the system. Okay, okay, a collection of entities that interact together over time to accomplish one or more goals. So the whole thing lah, maksudnya, so all this collection we call it a system. Okay, model ni is a abstract representation of the system. So model ni something yang you create to represent the real system. Itulah kita create machine. Okay, so we create like a box to represent a machine. So that is an abstract representation. Okay, system state. What is system state? Okay, it is a collection of variable. Ni variable that contains all the information necessary to describe the system at any time. Okay, so basically system state ni we use to describe the system at certain time, at certain point in time. Contoh, the example is the number of customer. So something that we can measure, we can count, kan, number of customer. Another thing is number of part in the system, the number of product in the system. Okay, and the server status, server ni atau machine. Okay, the machine or server status, normally the status of the server is either busy, being busy, or idle. Idle meaning that it's not doing anything lah. Okay, just waiting for the part or customer to be served. Okay, busy is when the server is processing the customer, right? Entity. Okay, entity, as I said, any object, any object or component in the system. Okay, that requires explicit representation in the model. So normally, kalau dalam technomatics tu, normally you will have to uh, choose an object kan to represent a machine, okay, to represent a customer ataupun worker, okay, a server. Alright. Attributes is the properties of a given entity. Contoh kalau part, produk, okay, attribute dia apa? It can be the color. Okay, ada certain color. Part can be blue color, red color, yellow color, okay. Or you can have priority of a waiting customer. Okay, this is attribute of the waiting line. Okay, when the customer is waiting, what is the way, well, how the customer is being priority. Contohnya, who will be served first. So we have the rule of first come first in, first come first come last out kan, first in last out for example, and so on. Okay, ataupun random. Okay, randomly serve. Okay, or the routing of a job through a job shop. Ni routing. Contohnya, for example, you have a product, okay, and certain product carry certain routing of which process they need to go through first. For example, product A, they need to go to machine 1, machine 2, and machine 4, for example. Product B, they will go to machine 1, machine 3, and machine 5, for example. Okay. So maybe certain product have different specific routing. Okay. So these are all called attribute, sifat-sifat dia, characteristic. Okay, list, a collection of associated entities ordered in some logical fashion. Ni list lah, a list. Okay. Contohnya, normally dalam simulation, list ni to represent the waiting line, customers order in waiting line. Okay. Contohnya ordered by first come first serve ataupun by certain priority. Ada contohnya produk A get higher priority, produk B get lower priority, for example. Okay. So list tu macam mana? Okay, macam mana you nak order the list? Ikut based on this rule lah. Rule that you specify. Event. Okay, what is event? Event ni instantaneous occurrence that will change the state of the system. Sebagai contoh adalah arrival. Arrival event. Contohnya customer arrive. When customer arrive, what state of the system that change? When the customer arrive. Of course lah, the number of customer in the system, right? Or the number of customer in the queue ataupun in the system. Okay, service beginning event. Service beginning event is also an event. It's an event lah, because a customer or a product receive the service. Okay, so it can change the state of the system in terms of, for example, the machine state. When the customer start a service, so the machine or the server become busy. That's the state. Okay, from idle change to busy. Okay, departure and service completion event. Okay, yang ini akan change in term of the number of customer in the system. Okay, it can also change the state of the machine or the server and so on lah. Okay, event notice. This is a record of an event. Okay, at current or future time lah. Okay, so this is necessary to execute the event. This is this record. Okay, no, event notice ni will have any associated data to execute the event. Okay, at least it will has the event type and the event time. Okay, nanti when we go through example, we will see lah how this event notice be represented. Okay, event list is a list of event notice. Okay, for future event. So this is normally ordered by time of occurrence lah. Dia ada chronological order, ikut chronological order dia. and it will be called a future event list. Okay, future event list ni. Activity. Okay, activity. Okay, this is something that you need to pay attention. Activity is a duration of time. Okay, meaning that dia melibatkan masa. It will involve time. Okay, specific duration. Okay, of specific length. Contoh, service time, inter-arrival time. Okay, normally this is something that specified lah, macam process time kan. Process time of a machine. You have to specify. Sama ada process time is a constant, 10 minutes for example, ataupun it is sample from statistical distribution. Okay, contohnya process time follow normal distribution. Okay, it can be deterministic or stochastic lah. Okay, completion of an activity is an event. Okay, an event notice is created in future event list for the activity's completion time. This is additional info lah for related to activity. Okay, delay, duration of time of unspecific indefinite lengths not determined by modeler ahead of time. Okay, so this is also duration of time, involve time. Tapi if activity is normally the time is specific lah ataupun specified, but delay is an outcome. Delay is an output, output for system, meaning that we cannot know ahead of time. Okay, we only know after we have observed the system. So that's why it's actually determined by system condition. Contohnya waiting time kan depends on service time of other customer. Waiting time is a delay. Waiting time is considered as a delay lah for the customer, right? Okay, which is depend on the service time of other customer. Okay, so what you need to know is when there is a delay, an entity is in the waiting line. Okay, this is an example of a call center. Okay, last time we went through a spreadsheet example of a call center and information service center. Okay, so from this example, okay, call center example, can you identify what is the system state for this call center? What will be the entities? What will be the events, activities, and delays? So here I give you example lah. Okay, system state, for example, here is system state ni normally it must be at specific time lah. Okay, time T, time at specified time. Okay, contohnya the number of callers waiting to be served. Okay, the state of the able and backer is the operator. Is the operator lah, service operator tu. Okay, the one that answer the call. So what is the state of these two operators? Be either being busy or idle. Okay. Entities for this system is the object lah, the object that flow through the system kan. Callers ni when they arrive, they go into the queue and then go to the server. Okay, service operator, the one that receive the service and end the service. Okay, event is something that change the system state. Contoh is call arrival. The caller, once the caller make the call, okay, there is a call arrival. It will change in terms of the number of callers waiting to be served. It can change the state of the operator, being busy or idle. Okay, service completion by able and also service completion by baker. So this one will also change the number of callers, okay, in the system lah. Okay, ataupun the callers already in the queue. Activities, remember activities ni must be related to time, related to time, period of time. So it can be the inter-arrival time, okay, or the service time by able or service time by baker. Okay, delay is a caller's waiting time in queue. This is as I mentioned before, is an output, right? Output of the system. Okay. Okay, a caller's waiting time in queue until able or baker becomes free. Uh, so as we receive the customer, okay, the calls, the new calls and the calls exit the system, there will be callers has to wait in the queue. That will be the call delay. So delay is related to time also, waiting time. So you have to mention you have to state the waiting time at what, at where. Yeah. In for example, here is in queue. In queue of what? Okay. Kalau in the production system, for example, the delay can be the waiting time for the product, right? The part to be processed, kan? Before at the certain machine. Okay. So basically, in discrete event, okay, the simulation will proceed, okay, by producing a sequence of system snapshot, system snapshots or system images that represent the evolution of the system through time. Evolution of system through time. So meaning that basically what the ES do is it will take a snapshot, a snapshot, okay, of the system or image of the system at multiple various point in time. So kita akan view we can view at certain point in time the snapshot of the system. What is the state of the system? How many customer in the system? What will happen after this? Okay, after that particular point in time, which is the future event. Okay, so give a given snapshot at a given time. Okay, a given time t. Okay, clock ni represent the simulation time. Okay, include not only the system state at time t, but also a list of all activities currently in progress. Okay, and when each such activity will end, the status of all the entities, the current membership of all sets, plus the current values of cumulative statistic and counters. Ni statistic and counters ni something that we want to collect lah. So, okay, we want to measure or collect based on the goal or objective of our simulation. Okay, contohnya we want to know the average waiting time in the queue. Okay, what statistic do we need? Okay, in order to get that value, to get that response, we call it response. Response time. Okay. All right. So, okay. In the next video, I will talk about this event scheduling and time advance algorithm, and as well as the assignment or homework that you need to do, okay, for this week.